Okay, so we're going to go through two examples of impulse, this idea of change momentum. And remember, there's two equations for impulse. There is impulse is equal to a change momentum of an object, or impulse is equal to Ft, where F is the average force exerted on the object, and T is the contact time. So for this example, it says a 0.35 kilogram piece of putty is dropped, that's key, dropped, meaning the initial velocity is 0, and I'm going to symbolize that as initial, from a height of 2.5 meters, so that's my height, above a flat surface. The putty comes to rest in 0.3 seconds, so that is a time value. Find the velocity it hits the floor with and the average net force exerted on the putty. So anytime that you are asked to find the velocity of something, the first thing you should think of is energy. Can I use kinetic energy to solve this problem? Because energy is nice and easy in that it doesn't have a direction. And so if we think about this, we know that our putty, like it starts here and then it like ends up there, okay? And we know the height. We know at this point it has a height of 2.5 meters, and here we have a height of 0. We know that we have an initial velocity here of 0, and we know here we have some final velocity value. So we could use conservation of energy to figure out what the velocity is right before it strikes the ground. So an energy I have here, I only have potential energy. So my potential energy at the top is going to get converted to kinetic energy at the bottom. So this is going to be mgh equals 1/2 mv squared. I have a mass on both sides, so those can cancel. And I get this relationship that says that V is equal to, if I multiply that over, so 2gh, and you should stop the video, calculate out what the velocity of this putty is before it hits the ground, and I get that it is 7 meters per second. Okay? So that's like right before it hits the ground. It has a velocity of 7 meters per second, and then 0.3 seconds later, it comes to rest. And so that is where we can look at the idea of impulse to figure out the net force exerted on the putty. So we know impulse can be equal to a change in momentum, and that impulse can also be equal to force times time. So if I set those two equal to each other, I have force times, I guess I write it as delta T, to be consistent, is equal to mv final minus mv initial. Now keep in mind, at this point, we are not looking at like its journey of falling down. We are just looking at this point here where it hits the ground with a velocity and then it has a velocity of 0 after 0.3 seconds. So my time is 0.3, my mass, it's 0.35. My final velocity after that 0.3 seconds is 0. It comes to a stop. So that's times 0. 0.35 times my initial velocity, which I found here was 7. And we can go ahead and calculate out the force. Again, you're going to be good students. You're going to pause the video. You're going to get out your handy dandy calculator and solve for the force. And I get that it is negative 8.17 newtons. And the reason it's negative is because when I said that it had a final velocity of 7 meters per second, I actually said, like, I'm just losing markers everywhere. I'm saying that, like, right here, it has this downward velocity of 7 meters per second. If it has a downward velocity of 7 meters per second here, like that's, and I call that positive, okay, I call that a positive value. If my force came out negative, what that means is that the ground is exerting a force in the opposite direction of 8.17 newtons. Okay, it's just that negative is just telling us that force is in the opposite direction as the initial velocity was. Okay. Okay, let's try one more example. The magic of whiteboard. 0.144 kilogram baseball is pitched at 38 meters per second. It is hit by a bat at the same speed, but in the opposite direction. What is the impulse? And if the contact time is 8 times 10 to the negative 4 seconds, what force did the bat exert? So initially, I've got my ball going this way at 38 meters per second, so that's my initial velocity. And then, oh my gosh, I don't even know if I could draw a bat, guys. The bat exerts a force, right? So it's going to exert a force, and it's going to make that baseball, this is not to scale, the baseball is going to go the other direction, and if it's the other direction, I have to note that with a sign value, so I'm going to say that that's negative 38 meters per second. Okay? So the first part of the problem just says, what's the impulse? And so I could just figure out what the change momentum is. That's just mv final minus mv initial. So that is going to be my mass of 0.144 times my final velocity of negative 38 minus my mass, 0.144, times my initial velocity of 38. And this ends up being a negative number, so you have a negative minus a positive, so it ends up being a bigger negative number. And I got that it was negative 10.944 kilogram meters per second. Okay, again, thinking about the negative. The baseball bat is causing a negative change of momentum. So it was going in this direction, and now the bat hits it, and it stops it and makes it go in the other direction. So that negative kind of agrees with conceptually what's happening. And then the last part of the question is, what force did the bat exert? So we know there's a time value, that it is in contact with the bat for a very brief amount of time. And so we know impulse is also equal to force delta t. So this negative 10.944 is equal to my force times my itty bitty time. Stop the video. Don't get rusty on your calculator skills. You should find that your force of impact, again, it's a negative because that force is being exerted opposite that initial velocity. I got that it was negative 13,680 newtons. Okay? So that is the basic concept of impulse and the different ways that you can calculate impulse.